For each case of confinement, this has different impact. I use the sink equations to see the impact. So some of them, they are increasing the value, or some of them, they are decreasing the value. So if you can see the figures that I show in the beginning.
For the critical pressure and temperature.
This case, like the effect of the confinement in the 2 nanometer, the shift in the critical pressure will increase, whereas in the 4 and 5 nano, the shift in the critical pressure will decrease in this case. Whereas the 5, the shift in the critical temperature change with the change in the nanopore size with the different values.
How long have you been working on this project?
I started working on this project since June last year, from June. So it's almost like 10 months.
So did you spend about 30 seconds a day on it?
More than 30 seconds.
So if you were to tell me on a daily basis how long did you work on it?
Like, it's not easy to tell because some of the weeks I was not working because I was busy with the classes. But in the last semester, I was like almost working every day, sometimes for 10 hours or 8 hours. I even appreciate the time of Dr. Amin to meet him every day in the break. So it was like, it was not equal, but I can tell like more than 3 or 4 hours a day.
I really think you have done a good job.
Thank you so much.
I really do. Now, no presentation on project is perfect. So if you were to criticize your own work, what is the weakness of this project? Or is it perfect?
No, there is nothing perfect in the real life.
So if this project has a weakness, what is it?
Like, I think it does not have a lot of weakness, but as my friend mentioned before when she presented her work, because we have the same work, we can use probably more pore size to study the effect of them. But we don't have this formula, and I think it's important to find what is the method to measure the pore size in the formations, like to have a good idea about the pore size in each formation or in each reservoir.
Are you writing a paper on this?
We are writing it.
I'll tell you what the weaknesses are.
Yeah.
All right. First of all, put that slide that you had the gas in place in there for different cases, for
Okay.
different models. Well, we have discussed many things, and he knows most of it. There are issues that we haven't had. Okay. Can you tell me why there is a difference in the gas in place? Because your model is the same. The porosity is the same, but you're not changing any of the reservoir
Exactly.
gases. Why there is a difference in the gas?
The difference is because the phase behavior is not the same. So we import different composition to the reservoir. It's the same composition, but it has different critical properties.
So what it is, your compressibility changes. That's
Exactly.
That's what happens to the
Exactly.
amount of the gas that you have. Okay. Now, one thing that you mentioned in your reservoir model is that you said that with the 2 nanometer, you get the best results. Okay. However, did your model consider that if you have a formation which is made of 2 nanometer pores versus a formation which is made of 5 nanometer pores, how does that affect the permeability and porosity?
Yeah, that's what I mentioned in the conclusion. Like, even though the reservoir, like, probably we can consider this effect, but it's not like a huge effect on the production, because there is like specific formula to calculate the change of relative permeability based on each pore size that we studied in the reservoir class.
So in fact, if I had a 2 nanometer, probably if I'm going to produce 4 million a day, I'm going to have much higher pressure draw as compared to a 5 nanometer.
But I think
that's my defect. I mean, I understand what you didn't do it, but that's a fact that you have to be careful when you're saying this. What will happen with this thing. Now we don't have a very good correlation to estimate the permeability based on the pore sizes and so on. And in reality, you don't have one size pore in the
exactly
reservoir either. So
we have mix of them, but I think we can find the range within the range, like the formation that has more pore size within the 2 nano or around the 2 nano will provide the best production.
One thing is that I want to double check to make sure you did that. When you were correcting your critical properties, the table that you have there, right?
Okay.
Did you also change the, let's go back, look at it right there,
This one.
okay. Did you change the nitrogen and CO2?
I change all of them.
But nitrogen and CO2 are not hydrocarbons. I mean, that correlation that you have, you keep in mind, that's only for hydrocarbons, right?
That's right. But in the same time, I noticed from
Now,
the
how much
results.
nitrogen you have? I mean, you have the composition.
Yeah.
It was significant or not?
It's not that significant.
Yeah, CO2 and nitrogen was very small, you know.
Mhm.
Whether you want to change them or not, that's a different question. Particularly for nitrogen, because nitrogens are very small molecules
Mhm.
as compared like this, ethane and propane are big molecules, so the confinement has more effect on them.
Exactly.
But when you look at nitrogen, it's a very small molecule, so the confinement doesn't have any effect on it. Now CO2 is a little bigger, so
Exactly.
that's something to keep in mind that
Also, I noticed like the biggest change due to the confinement is on the heavy component, because the heavy component has higher molecular weight, and we saw earlier that all the calculation of the change in the critical properties is based on the molecular weight. So for this reason, like I didn't consider the nitrogen, but I think it will not make a lot of changes in the calculation.
No, one thing, this is just a hypothetical question, and I know there's not an easy answer to it. But if I have a reservoir, okay, and it is having different size pores, okay, would this effect be significant? In other words, if I have some 2 nanometer pores and some 5 nanometer pores, okay? Now, as a whole, wouldn't they cancel each other out? I mean, some part of the reservoir will affect this way, some other goes the other, because you're opposite, right?
That's right.
So, would we see this thing or not?
I think we will see the impact of the 4 and 5 nano,
Right.
because they are causing the
Dew point to rise.
dew point to rise, so we will have more condensate in the reservoir, so they will neglect the effect of the 2 nano, even though we have open pores, but the way in front of them, they will be closed.
Well, it depends on the distribution of the pores. We can tell how it would actually behave. But yeah, it's possible that it have some impact on that.
Exactly.
Now, one other thing that, of course, we have discussed this thing, we couldn't do in the modeling work, is that once this gas enters into your hydraulic fracture, it no longer is confined. Okay, so it's very likely that even though you're delaying your condensation in the pores, but once it comes into hydraulic fracture, because now you have a huge pores under, right?
Exactly.
So it's going to reverse and start dumping all the liquids again.
But I think this effect is not that significant because the size of the fracture is bigger compared to the formation. So even if we have condensate in the reservoir, it might be like the condensation, the concentration or the saturation of the condensate might be higher, but still like the hydraulic fracture will be open for the production.
Okay, very good. Any other question?
Did you already find the confined density too? Did
I
you have
didn't include the confined density because I think it's not really important with the other properties. So the model just like I import the critical pressure and critical temperature.
for the viscosity part?
Either the viscosity because this is the provided formula for just these critical properties.
Well, if you change your critical properties, it affects the viscosity too, right?
That's right, actually.
So probably we could adjust the viscosity, yeah.
This is sort of for Fatima too. I know you did some work on the confined effects with the adsorption in the confined pores for your PhD. Would you say that it would improve our gas in place estimate if we put the absorption in the gas in place formula? Because me and Irfan are going to publish
Yeah,
a paper
there's
together and we were
something
thinking about doing it.
Absorption? Yeah, it should have some effect, but not that much.
Now, your model does not account for.
It doesn't
absorbed
account for
gas, right?
absorption.
Actually, one of
Yeah.
the models I consider
Absorption.
gas.
the absorb like from the parameters from the
Yeah,
performance.
one of the things with the adsorbed gas is, what we have done in the past and what we find out. The desorption effects are insignificant at the start, the first few years of the production, because your pressure is too high for
Exactly.
the gas desorption to have any impact. Unless, of course, there are different theories about the desorption take place and so on. But if you go by Langmuir theory and so on, then you have to lower the pressure enough. So probably you see the effect of desorption maybe 5–10 years
Exactly.
after the production, and that it becomes insignificant because if your well doesn't pay off in first 2 years, you're losing money anyway. So it doesn't matter how much you produce after 5 years. Okay. Any other question? Yeah.
Did you use different permeability values for 2 nanometer, 5 nanometer?
Well, this is the same question that Dr. Amin asked me. Like, we should consider this by using some formulas, but I think the change is not that significant because they are really close.
The permeability values for 5 nanometer and 2 nanometer is totally different, I think.
Yeah, we need to account for some effect of the permeability and viscosity in there, but although in this case you didn't do for this study.
Are there correlations out there for the 3 nanometer, 2 nanometer, and 4
Permeability?
for the?
There is no correlation for nanometer permeability. There are
Yeah.
correlation for pore size versus permeability. You can
So
add
in
them to.
order to get the permeability values, you would have to do your correlations yourself for the nanopores.
Yeah, there are correlations.
There are some correlations. I mean, we don't have to be perfect, and you can actually say, okay, assume that 5 nanometer and 2 nanometer, whatever permeability you give one, you want to either increase the other one or decrease the other one. So
Exactly.
be proportional. It doesn't have to be the exact number.
But besides that, like, I think the permeability will not change a lot because base of our production is from the fractures. So I think it will not be that significant if we change the permeability. Like, you probably will see slight change, but it's not significant change.
Well, the permeability is so low in the formation that adjusting that may not make a huge difference. The reason we have the most of the production because of hydraulic fracture, initially anyway. It takes like 10 years before
Exactly.
formation permeability affects you. So.
Because the production from the unconventional resources is like a function of the fracture, hydraulic fracture permeability, not like the permeability of the matrix itself.
Does the size of the pores affect the porosity too? Is there any correlation between them?
Technically, no, and it could. I mean, if you assume everything is 2 nanometer, okay, or everything is 5 nanometer, it's just basically within the 333. If your particles are all the same size, porosity is not affected. Okay. Now, of course, if you have non-uniform sizes, yeah, it could be affected.
Do we know, for the original work, the pore size selection, was it, randomly or there is a criteria behind it, like 2, 4, 5? Why 2, 4, 5?
Because I think the 3 nanometer like didn't show like a huge change. Like if you go to this figure, you can see this is the 2 nano, this is the effect of 4 nano, this is the effect of 5 nano. So the 3 nano.
But what is he asking? Why 5 nano? Why not 8 nano? Why not 12 nano? Why 8? What is the significance?
I think they selected these pore sizes based on the more pore sizes they found in the matrix, like just doing the.
But what will happen if you go over 10 nanometers?
We will have the unconfined case.
So 10 nano is the limit, right?
Exactly.
Right.
It gets closer and closer to the unconfined cases.
Which is the first case that we studied.
Yeah.
Well, now, in the past, the students were not allowed to ask questions, am I correct?
Well, we
Here-
could allow them or not. I
Yeah.
let them ask questions.
Here this guy comes with a very, very good presentation, and he has all sort of food here. And the students here, your peers, basically are eating and asking you questions, so we can just go on. The food is here, we are here. So we give it another 5 minutes.
So you can eat as much as you want. The next 5 minutes.
Are there any other questions?
If there are no other questions, we would like everybody to excuse.
Okay.